Sci-fi is in its very nature fictional science, and pushing the boundaries of the real world is what makes it so awesome. But in order for the stories to be at all believable, they are usually bound by the physics of the universe we know and love. Otherwise, everything would be flying marshmallow unicorns, spurting caramel. Exactly, it wouldn't make any sense.
So for now, let's step away from science fiction and get a healthy dose of science fact, and find out who's getting it all wrong on the silver screen. I'm Stu, this is Debunked, and we're here to talk the truths from the myths and the facts from the misconceptions. Let's kick things off with a bang. Literally.
Whether it's an intergalactic dogfight blasting ships out of space, or undocking complications that end in catastrophe, space movies love a burning fireball of an explosion. Except they wouldn't look like you, and many movie directors probably imagine them to. Fire is caused by the combustion of gases in air, and as we all know, there's not a great deal of the stuff in space. In order for fire to exist, it needs an oxidizer, but that doesn't necessarily need to be air. It could take the form of liquid oxygen or hydrogen on the spacecraft. So the laser blast that's tearing open the ship could cause one of the oxygen tanks to combust. However, the fire can only last as long as the oxidizer does, and it would all be burned up in an instant, meaning you wouldn't get the Bayhem-style explosion the IMAX was designed for. In fact, an explosion in space would look more like this. A short burst of spherical light. The force of the explosion would still be powerful, it just wouldn't look as dramatic. And it wouldn't matter how powerful the explosion. Not even a nuclear bomb could satisfy Michael Bay's intergalactic pyrotechnical needs. How do I know? Well, they tried it. Not for yet another installment of Transformers, but instead for a series of experiments called Operation Dominic during the Cold War in the early 1960s. The program of atmospheric tests saw a 1.4 megaton bomb detonate 250 miles above the Earth, and it looked like this. Devastatingly beautiful, but not the fireball you'd normally see.
Now this brings us on to something else that's always done wrong.
The deafening sound of this sort of explosion wouldn't actually be heard at all, because Ridley Scott was right. In space, not only can no one hear you scream, they also wouldn't hear you explode. Sound travels by banging a load of molecules into each other, but as we've just discovered, there aren't the traditional molecules like air for sound to vibrate through in the vacuum of space. And here's an expert to debunk what I've just said about space being a vacuum.
Space is not a vacuum, although admittedly it's pretty close. There is stuff between the stars, just not very much of it. The density of matter in space varies over a wide range, but a typical density is about 1 hydrogen atom per cubic centimetre.
Now that might sound like a lot more molecules per cubic centimetre than you'd expected in space, but for comparison, air is around 1,000 million times more dense. So sound can travel in space, it's just not dense enough so that we can hear it. But to be honest, I think audiences would prefer they continue to take dramatic license on this one, unless they're into silent battle scenes. Although Kubrick got this right in 2001: A Space Odyssey. But this doesn't mean the universe is in total silence everywhere except on Earth. Where there is atmosphere, there's sound. But again, it wouldn't sound how you'd expect. On Mars, for instance, sound will be higher in pitch, which would make The Martian more of a comedy.
I'm definitely gonna die up there if I have to listen to any more god-awful disco music.
And could explain why Marvin the Martian talks like he does.
Yes. Very curious. Very interesting.
Now let's head away from Mars, like they do in the movies. Really fast. We're not here to debate the science behind actually achieving light speed, warp speed, or...
No, light speed is too slow.
Light speed too slow?
Yes, we're gonna have to go right to ludicrous speed.
That's for another video. What we're going to look at here is the acceleration of getting to any of those speeds.
Now, the problem with getting a spacecraft to light speed, for example, are the passengers inside it.
Don't strap yourselves in. I'm gonna make a jump to light speed.
Now, when the ship is suddenly jumped to 186,000 miles per hour, inertia would cause Han Solo quite the problem, because he would be thrown back into his seat with such force that he'd splatter all over the freshly cleaned leather. As an astrophysicist from NASA explains,
the gravitational force on an object is equivalent to the inertial force on an object undergoing a comparable acceleration. Just as gravity pushes you down against the Earth, inertia pushes you back against your seat.
So, if we wanted to see Chewie and the crew arrive in one piece, then, according to author Jean CAVELOS, a former NASA astrophysicist, accelerating safely to light speed couldn't be done in an instant. It would actually take months. The level of G-force that a human can safely withstand is around 9 Gs, and this is only for a very short period. Anything longer than a few seconds, and you will pass out and die. This is because the number of Gs you experience makes your body feel that many times heavier. So at 9 Gs, you feel 9 times heavier, and so will everything inside you, meaning your heart will struggle to pump this heavier blood to your brain. CAVELOS suggests accelerating at a more survivable 3 Gs to get up to light speed, something we can normally only suffer for around an hour. But even travelling at 3 Gs, it would still take 2.5 months to reach light speed. Hardly thrilling viewing.
I'm going to safely bring us up to light speed. Almost there.
But what does have you firmly planted on the edge of your seat is stuff like this. Located between Jupiter and Mars, our asteroid belt, or main asteroid belt, is usually referred to as a dense circular field of asteroids that's near impossible to pass through.
Sir, the possibility of successfully navigating an asteroid field is approximately 3,720 to 1.
Never tell me the odds.
And to be fair, when you look at a diagram of it, you'd be forgiven for believing the worrisome droid. There are up to 1 million asteroids that are over 1 kilometre in diameter. And understandably, you'd want to avoid crashing into one. But the truth is, each asteroid is also several kilometres apart from each other. Several million kilometres apart, in fact. So far that if you were stood on one, it's likely you'd not even be able to see your neighbouring asteroid. And if you combine the total mass of the entire asteroid belt, it would only equate to around 4% of our moon. According to David Morrison from the NASA Ames Research Centre, the average 1 kilometre asteroid only suffers a collision once every billion years. So, far from being impossible to navigate your way through the asteroid belt, you would actually have to go out of your way to hit one. Thank you for watching. Check out the video that's on screen now, and if you haven't subscribed, then please click on the button below. We have a Patreon page, and if you'd like to support us, click on the button and check out our rewards. We want to make more videos, and it's your support that helps make this possible. Thank you for watching, and we hope to see you next time.